Welcome to Easy Math TV. We're going to continue our um, discussion of statistics, and in this case, it's still part of our descriptive statistics um, section of our class, and we're going to focus on a population today. In fact, we're going to focus on a population that has a probability distribution. Okay, so what you see in columns A and B over here is what we call a probability distribution, and I'll explain that. And then once we type that in, that's information that is given to us. We're going to use that information to calculate something called the mean, which is our measure of center, and our standard deviation, which is our measure of spread. Okay, so before we get going with columns A and B, I just want to introduce you to two new symbols. We have two Greek letters that represent population parameters. The first Greek letter is the Greek letter mu. It's pronounced M-Y-O-O, mu. Um, Looks like what you see here. And that is the symbol for the mean. The symbol for the standard deviation is the Greek letter sigma. Okay, so you can see those here. I just wanted to show them to you. Um, this is stuff like if you're setting up your own spreadsheet, you don't need to put this in. This part down here, this is just for you to see that we are actually dealing with something that's treated as a population, even though it came from a sample, but we're treating it as a population. Okay. All right, so the first thing I should point out to you is that our data is, what does it represent? These X's are the number of times that patients ring the nurse during a typical shift. So any shift, whether it's night, day, whatever. It's during an 8-hour stretch, how many times do patients tend to ring the nurse? Okay, that is our population. So our outcomes X are 0 times, 1 time, 2, 3, 4, and then the 5 is really 5 or more. There weren't that many of them at this particular hospital, so these are our numbers. These are our outcomes: 0, 1, 2, 3, 4, and 5 or more. All right. So those are our categories, X's. And you'll notice that that is discrete data and it is numeric data because it's counting something. It's counting how many times something happened. So in column B, we have our relative frequencies. And I went in and I calculated them, even though those numbers were given to me as a fraction. So um, the information that I had in front of me said that the probability of a 0 was 4/50, or 4 out of 50. So in Excel, I just typed equals 4/50 and it calculates that as a decimal, which is fine. So every one of these numbers was entered in by hand. I just copied it from the data table that was given to me. So this is basically our probabilities. Okay, these are the probabilities of these happening. So in cell B3, that is equals 8/50. In cell B4, that is equals 16/50. In cell B5, that is equals 14/50. In cell B6 equals 6/50. And in B7, this was equals 2/50. Okay. And down here notice that my totals row is in row 8. If you're going to be doing this with your own data, you may have your totals row further down. It all comes down to just how many values of X you actually have. My table is pretty short. There's only 6 outcomes, 6 distinct outcomes, 0 to 5. But you may actually have more than that, but I'm going to be referring to the totals row as row 8, okay? So let's move this information aside here. Okay, so we've just typed in our data, and down here in the totals row, I just want to verify that all of my probabilities add up to 1. So I'm going to equal sum up all those numbers in column B. So in row 8, in cell B8, I typed equals sum parenthesis B2 colon B7. And just to be a little time saving here, I'm not going to go into detail about the sum thing again. Like, the totals row is going to be the same all the way across. Um, so that's always going to be the sum of the cells above it. You know what I mean? So I'm not going to go into all kinds of detail about that. And that is equal to 1. You can see that there's a 1 there. So all of our probabilities need to add up to 1. That is absolutely essential. Had they not, then we would have had to go back to our data to see if we made a mistake or maybe a number was entered incorrectly. But those numbers do have to add up to 1. Okay. All right. Let's go into these now are our calculations. So this is going to produce our mean and our standard deviation for this population. So column C heading is expected value or mean. So the first thing we do is go into cell C2 and type equals A2 times B2. So that's just your value of X times its probability, okay? X times the probability of that happening. So equals A2 times B2. Hit enter, and then you can use your anchor and fill that formula all the way down. Notice that the formula in row 4 is equals A4 times B4. So it's always multiplying the value of X that's in that row times the relative frequency in that row. Okay. Now this is the mean. The mean, which I've highlighted that cell blue so that I can see it better going forward in the future. The mean is the sum of all of those numbers that we just calculated. So just sum up all those values in column C and you get your mean or expected value, which just means that on average we expect patients to ring the nurse approximately 2.32 times on average. So obviously, you can't actually ring the nurse that many times, but that just means that you'll have a certain number of people ringing twice and a certain number of people ringing 3 times. That's the bulk of your data. You can actually see that the likelihoods are a lot higher for those. In fact, if you add up the 0.32 and the 0.28, you actually get 0.6. So 60% of the time, patients are splitting their the number of times that they ring the nurse between 2 and 3. So yeah, so that's your mean. That's your mean right there. And then we're just going to copy that into column D. So just copy that over to make our calculations easier for column E. Expected value then is equal to $8. Equal to $8. And that's going in D2. And again, we're just going to fill that down as well. Just copy that down as many times as we need to in order to calculate the variance, which we're about to do. So that should be the same number. Everything you see here should match the number that you see down here in C8. All right. Now, column E is the variance. The variance is another statistical measure, okay? It measures variation. Variation. So in cell E2, this is the only complicated formula that we have to enter. Everything else is easy. In cell E2, you're going to type equals parenthesis A2 minus D2. That's your X, your value of X minus your mean. Close parenthesis. And then we need this caret. The caret symbol is your exponent key in Excel. And the exponent is the symbol that's right above the number 6 on your keyboard. So hit that exponent key or that caret key and type 2 because it's being squared. And then times, and then B2, which is our probability. So equals parenthesis A2 minus D2, close parenthesis, caret or exponent 2 times B2, hit enter, and you can fill that down. So the way you would see that formula in a textbook is down here, which I typed in for you so that you could actually see what that actually looks like. So basically, what you have, what we've translated into cell references is basically x minus mu, the quantity squared, times p of x, or the probability of x. Okay, so we just translated that into cell references, but that's what that is. Okay, fill that down, and at the bottom here in column E, at the bottom where it says totals, you're going to sum those up. So sum E2 colon E7. All right, adding up all those variations gives us our total variance. Now sigma, the standard deviation, is literally just equal to the square root of that variance that we just calculated. So equals square root of E8, and that's going into cell F8. All right, so outcomes X, relative frequencies, expected value mean, which is in column C. We calculated the variance in column E, and then we calculated the standard deviation in column F. Those are our population parameters for this population of patients at a certain hospital. And it represents the number of times that they would ring the nurse during a particular shift. So like, subscribe, comment down below. I hope you're enjoying these videos, and I hope they're helping you do the kind of the harder stuff so that you can actually just focus your efforts on interpreting and, analyzing the numbers that you see in front of you. And I'll see you in the next video.